Now let's look at some limits involving composite and trig functions. Suppose I have two functions f and g, so that the limit as x approaches c of g of x is equal to L, and the limit as x approaches L of f of x is f of L. You see how we did that translation there? Then the limit as x approaches c of the composite function f of g of x is equal to the function f applied to the limit as x approaches c of g of x, which is f of L. Now this looks a lot more complicated. In practice, it's very straightforward. As a matter of fact, this little bit of sleight of hand has some really cool mathematics behind it, but it is very easy to use. Now similarly, the limits of trig functions are straightforward. If c is a real number in the domain of the given trig function, then the limit as x approaches c of sine of x is sine of c. This is the same sort of concept where we're doing a composite function of sorts. So let's look at this function right here, and I'll do this with all of the painful little steps. The limit as x approaches 1 of cosine pi of x. Well, let's treat this as a composite function. So I could kind of slide this limit in there. This will be the cosine of the limit as x goes to 1 of pi x, which is cosine of pi. And you know the cosine of pi, put your equal signs, is equal to -1. Let's look at this one right here. This is the limit as x approaches 0 of x squared plus 4. Now, if I ask you to use the composite rule, all right, then you do need to change this into the limit as x approaches 0 of x squared plus 4 raised to the 1/2. And then say this is the square root of the limit as x approaches 0 of x squared plus 4 to the 1/2. And so this is, let's see, 4 to the 1/2 or 2. Now yes, this is an awful lot of steps when you could have just plugged it in and said square root of 4 is 2. But this is showing you how to use the composite rule. You won't always have an explicit function, and so you need to be able to go through with the steps. Now, we can do this one the easy way or the hard way. It doesn't matter to me. The limit as x approaches 3 of the cubed root of 2x squared minus 10. We're going to make this a cubed root. So I'm going to slide my limit inside here. So this is the cubed root. So the limit as x approaches 3 of the inside is 2 times 9 minus 10. So this is a cubed root. So this is 18 minus 10 is 8 to the cubed root, or 2.